Hey, so here we are with the very first video for geometry, right? And it's just a basic introduction. So, we're just gonna start by saying, what is geometry, right? Well, the word geometry itself comes from the Greek words meaning to measure the earth. So geo, which is the earth, and metry is to measure. So to measure the earth. Alright, and basically, geometry is a study of shapes and is one of the oldest branches of mathematics. And actually, what we're going to talk about next is a book that Euclidean wrote, okay? And what you'll notice is that this book is called The Elements. And you have to remember, back in Greece, their elements weren't hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, and so on. Their elements consisted of four elements. It was fire, earth, wind, and earth. Fire, earth, wind, and water. It was four elements. So if you think of that and kind of think geometry is the measure of the earth and its different shapes, I don't know, you kind of make that connection. Kind of think of that. But the next thing, right? The Greeks and Euclid. So there are two types of geometry, right? There are two major types, and the major type, the most major type, because even though there are two major types, there's one major type out of those two, and it's called Euclidean geometry. And this is the geometry most commonly called geometry that's taught in high schools, and you don't even begin to touch non-Euclidean geometry until you get into college, until you get into the math degree fields. If you're mastering in math, specifically in the area, you'll do it. But if you play games on your phone, there's a great game called Monument Valley, which is a complete and utterly awesome game, which is about this princess. He has to go through these ancient monuments, and the mystic monuments, and it's all based on non-Euclidean geometry and how it manipulates the shapes, and you just have to go and look at it yourself. Even if you can't play it, you can't find it, I'm sure you can just look up Monument Valley and you'll be able to see pictures and videos of other people. But to go back to the Greeks and Euclid, what we're going to be doing is called non-Euclidean geometry, right? And it's basically our modern understanding geometry, right? And it began. So the Greeks and Euclid, our modern understanding geometry began with the Greeks, right? It wasn't the Romans. It wasn't even the Arabics, right? They did a lot in algebra. They did a lot in algebra. They invented the number zero, the Hindus and the Arabics and all that. But in Greece, the Greeks, over 2,000 years ago, a bloke named Euclid was in this secret, it wasn't so much a secret society, but he was in this upstanding scholarly academic society, and they did a lot of math. Math was their thing in Greece. If you look at their architecture, it's nothing but geometry. So the Greeks, though, unlike other civilizations, they didn't care so much about what was there. They wanted to know why it was there. And you can even see this not only in geometry, but if you go to chemistry, the whole atomic theory started with the Greeks, with Donomus, right? And he created the name atomos, or non-divisible, and he started the whole thing. What is everything made out of? Well, small indivisible particles, or he called them matter. And then they're like, well, no, everything's only made up of four elements, which is Euclid's book. But again, sorry, I keep saying again, I keep getting off topic, but you can see in many aspects of Greek culture that they didn't really care so much about what things were. They wanted to know why things were. And if you're watching this video, you're most likely in honors geometry, which is what this lesson is based off of. Take note that every geometry lesson Justin Maths offers is based off an honors geometry curriculum. So if you are not in honors geometry, either most of this will make no sense, or, because I'm not calling you dumb, I'm not. I mean, honors geometry is fun. It's not hard. It's just more rigor and it's more in depth. So either A, you won't understand it, or B, what you're covering in your regular geometry class has nothing to do with what I'm teaching or what other students are learning in honors geometry class. So that's why at the beginning of honors geometry class, we start with an introduction to geometry and we start getting into history to help you understand or comprehend or wrap your mind around the concept of honors geometry, opposed to where if you're in regular geometry, you just start right off the bat with definitions and getting into the curriculum and so forth. So, next point. It was around 350 BC, though, that Euclid of Alexandria. Alright, now, you keep hearing me mention this guy, Euclid. Well, who is this guy? Well, this guy was a mathematician, again, as I said just a bit ago. Euclid was a mathematician, and he's probably one of the most notorious and respected mathematicians, not only in his time, but throughout all of history. And he is accredited for discovering geometry, because what he did is that he wrote this book. He wrote this big giant book called The Elements. And what he did in this, he wrote down everything in a nice systematic order. Alright, he wrote down everything that was known about geometry. So even though he might not have discovered it all himself, because he's only one man, he was the one who put it all together. And actually think about it, that's kind of what our hope here at Justin Maths is. Me or anyone else on our team, that we haven't really discovered anything so much. It's already 2016. We were born in the wrong age for discovering things, But we're trying to collect everything and put it together systematically for you to have and to learn. And that's what Euclid did. So he wrote this book called The Elements, right? And again, you can tell that he wanted to prove why, right? And moving on, here's the elements. So knowing that you can't define everything and that you can't prove everything, Euclid began stating 3 undefined terms. So Euclid didn't really define these terms. He just kind of stated them, right? And he stated what a point is. And these 3 terms, I'm not really going to focus on them. We don't need to focus on them today. There's no need. We can get to that in the next lesson. We can get to that next time, right? Because actually, the next lesson is points, lines, and planes. But we don't need to you probably guessed what the 3 key terms are now. So he kind of just went over these 3. Knowing that you can't define everything and that you can't prove everything, you have to just state something. Some things just have to be for it to work out. And what we say by you can't define these things is that there's no way that either A, these can be built or fabricated in the real world, which none of these 3 things can be, and there's no way to really comprehend your mind around them. It's like when we start getting into quantum physics, right, or quantum chemistry, you just kind of just have to accept it. You just have to. Alright, a point is that which has no part. It's just a dot on a graph. But this dot has no width, it has no diameter, no length, it takes up no space whatsoever. It's an idea. What it is, it's a concept in our mind in which something is located. But the point itself plays no part in it. It's nothing. It has no part. Nothing. Nada. Zilch. Zero. It's hard to comprehend. Because we're so used to when we write it down, we're so used to seeing it written down on a graph as a dot. But when you take the literal definition of it, it's nothing. So knowing that you can't prove that there's nothing there, because how can I prove that the thing that I'm using to prove other things doesn't really exist? Because once I do that, which can't be done, everything else doesn't exist, or it just falls apart. So these three concepts, just know them, kind of glance over these definitions. So a point is that which has no part, and a line, a straight line, is a line that lies evenly with the points on itself, and a plane, or a surface, is a plane that lies evenly with the straight lines on itself. Now, whether this makes any sense to you or not, alright, and I'm not talking philosophically, I'm talking about whether you've been in a geometry class or you've taken, like what I did, is that I took college geometry the summer before I went into actual geometry, and I had dropped out of Geo Honors, not because it was hard. I was only there for a day. I dropped out of Geo Honors, went to regular Geo, and I went to Algebra 2 Honors, so I doubled up on math so I could do pre-calc the next year, because, well, I just didn't care about school my 8th grade year, and I didn't try at all. Like, I just didn't care. I wasn't always an academic tutor, and I didn't always love school. So I had to get back on track. But whether you know this or not, don't worry about these three definitions. Whether this is confusing or makes sense to you, don't worry. We're going to get into these three topics again next time. Right? So now basic terms. Alright? Now we're just going to go over basic terms. Alright? A ray starts at a point called the endpoint, and it extends indefinitely in one direction. Right? So you have your point. You have your starting point, okay? So let's imagine these are real life, okay? So we're not going to get into our philosophical understanding until next lesson. Let's all imagine this is physical, okay? So I have my point. And let's make this into a map, alright? Let's say point A is my home, right? Point B is the grocery store. If I draw a line from my house through the grocery store, a straight line, beginning at my house. So it's not really a line, this is a ray, okay? So, but let's say I start at my house, and I start drawing in a straight line as to where I pass the grocery store, and then I continue drawing infinitely long. I start drawing indefinitely. I never stop. I'm gonna die out there. No, I can't die because it has to be indefinitely. It has to be infinite. It has to go on forever and ever and ever. And yeah, again, this is where we get into the philosophical debates. What is forever? What do these arrows mean? And that's actually what the arrow means, because obviously by the time you even get to the point where you're going to start drawing all the way out your school or out your house and going, you know, before you can even get to that point, you're going to run out of paper. Right? So if you're at your desk and you're doing homework and it tells you to draw a line, you can't really draw indefinitely long lines. Not how that works. You're going to run out of paper at some point. So what we do is we draw these arrows. These arrows tell us this here is indefinite. It is infinitely long. Right? So starting from point A, I draw a ray. Now here's how you remember a ray. A ray is a one-sided line. It's a one-sided line, right? I forgot the word line for a second. A line has two arrows, one on each side, right? A ray has only one arrow, at which point, where the other arrow would be, is an end point. We call it the end point because it's at the very end of the line. You know, it doesn't go indefinitely. But it does stop. It just stops right there. In which case, we just throw a point on there, and that's our starting point. But you know, logically, again, as you're moving from an indefinite position to a non-definite, you would be coming from that non-definite to that indefinite. And you'd be coming from that indefinite to that definite point. You know, why would you start from a definite and then walk forever? You would get tired. You want a destination. So, And it's only logical for some part, because you can try to play devil's advocate and say, argue against me and say, well, how can you come from an indefinite path? Where do you start then? Well, again, you kind of just have to wrap your mind around it. But just know that it's called an endpoint. So array starts at an endpoint. Now we say starts in this sense. If you want to use the explanation or the remembering trick that I gave you just now, we say starts. This is one way to think of it. We say starts because when you're drawing, you want to be able to neatly start at a point and then draw on and then draw your arrow. So in order of drawing an array on a graph, on a piece of paper, you want to start at your endpoint and extend in one direction. Then put your second point, and you'll understand why we have a second point when we get to our next lesson. Now, we also have a line segment, and a line segment is it's a segment. So instead of having so you have a line. A line is where you have two ends that extend indefinitely, right? Then you have an array where you only have one end that extends indefinitely. Well, a line segment is just a part of a line. So if you think about it, now array is where you just cut the line in half, and think about it, a line is indefinite. It's infinitely long in both directions, so no matter where you cut a line, you're cutting it in half. So array is where you cut a line in half and you keep half of it. Well, a line segment is where you cut a portion of your line and you keep it, right? So let's say you have a piece of string and both ends extend forever, infinitely long, right? And I cut it. Well, and I only keep one. So now I just cut it, so this part doesn't extend indefinitely now. So I tie a knot there. That knot now becomes my endpoint, right? But I still have one end that's indefinitely long. Okay, that's infinitely long. It's indefinite. Well, now let's say I cut another piece, right? Well, that indefinite piece now is gone, and I keep the part that had my knot on it. Now I'm going to tie another knot at the other end. Now I have a definite segment. I have a segment from my line, right? I have two rays out there in the garbage can, and I have a segment right now, and the segment has two knots on both sides, and now this is my line segment. And when we're writing this, right, every time we're talking, if I'm talking about array in a sentence, I can't just stop in the middle of a sentence, draw a graph, and then draw an array, and then start moving on my sentence again. I have to be able to either verbally say it, or I have to be able to write it down. Well, the way to write it down is to put your points, and we'll get more into this again in the next lesson. This is just an introduction, but to get more into this, by writing the two letters, they're always capital, write the two letters of the points, and then to put array symbol. And the array symbol is, as I said earlier, just a line, or it's a half a line. So you draw a small line. See, now this is where it gets hard, because in everyday use, a line is just a mark you make. In geometry, a line is an indefinite, is where both sides are infinitely long. So this is where it starts to get complicated explaining this. You're going to put a dash, there we go. You're going to put a dash above the letters A, B, and then you're going to put an arrow on one end. And then for a line segment, you put a dash above the letters and have no arrows. And for a line, you put the dash above the letters and you put arrows on both ends. So now that we have the lines down and we have our rays down, what can we start doing with these? Well, we can take our two rays and we can make an angle, right? So an angle is formed by two rays with the same endpoint, and this endpoint is called the vertex, okay? Now, an angle is measured in degrees. You might be asking, well, what do you mean an angle is measured? What does that even mean? Well, when I ask you to measure an angle, if I come up to you and I say, hey, John, or, hey, whomever you are, how much space Or what is the distance? Here's the question. Here's how we word it. What is the distance from point A to the of line B or ray B to the correlating point on the ray X? So in other words, basically, if you look at the angle that we have drawn here, it can give you a visual representation. If you look at the angle given here, right, you can tell where the smallest amount is. So imagine it's a circle, right? So imagine this angle is inside the circle on the right, right? I want to know, and this is an acute angle, right? I want to know what is the distance, if I was walking in a circle, what is the distance on the smallest portion? And now if it was an obtuse angle, what is the distance on the outer portion? Okay? And this distance isn't measured in miles, it's not measured in time, minutes or seconds. It's measured in a unit called degrees, okay? And now a circle has 360 degrees. So if I walk in a full circle, I just walked 360 degrees. Gonna burn these calories off immediately. Right? So remember that about the circle. So that's going to help you now to understand a straight line. Now, before we get into that, a right angle has a measure of 90 degrees. And these are some things that we have to memorize. There's no easy way to get around it. We have to memorize these. So right angle is when our rays come together in our vortex at a perpendicular point. So the point in which our rays meet are perpendicular, which means there's a right angle. And you might be thinking, well, the definition is kind of redundant. You don't help me understand by just restating the definition you already gave us. But there's really no other way to explain it. Now, I did provide a visual representation, though. So here's a visual representation. It's exactly what I just said. I'm not going to repeat myself, really. It's exactly what I just said. And here's a visual representation on the right. So you can look over here. Here's a visual representation. And this little box here indicates it's a right angle. From here on out in geometry, if that box is not there, you cannot, I repeat, you cannot, N-O-T, you cannot assume that that is a right angle. Just because it looks like a right angle, unless it is written on your paper, unless it is written on your assignment, unless it is written somewhere in your textbook, that it's a 90-degree angle. You may never assume that is a 90-degree angle. That is so important. You will get so many things wrong. And depending on your teacher, I know my geo teacher counted everything wrong when I assumed things. That's what, in your honors, you lot are honors, you're in honors geometry. You're honor students, and you can't assume things. The whole basis of honors geometry is this, understand why things are. Why is this a 90-degree angle? So you can't go and assume that's a 90-degree angle unless it tells you this 90-degree angle. You can't assume that's a 90-degree angle. And with the straight angle, a straight angle is always 180 degrees. So if you think about it, a circle is 360. Well, let's say I only walk half a circle. Let's go to semicircle. Let's say I walk a semicircle, right? Let's say I walk a semicircle, and this is the distance of the diameter. Well, it's only going to be 180 because I only walk half the circle. And what's 360 divided by 2? Well, it's 180. That's a simple way to remember it. Now we get to curves and polygons. A simple closed curve is a curve that we can trace without going over any point more than once, while beginning and ending at the same point. So kind of think of a circle. With that definition, it kind of sounds like a circle, right? So a simple closed curve, yeah, a simple closed curve, that is a circle. This is the definition of a circle, pretty much. There's some other key aspects to define a circle, but this is a simple definition of a circle. Is a curve that we can trace without going over any point more than once, while beginning and ending at the same point. Okay? Now, polygons. You don't worry about curves. Listen to me, please. Don't worry about curves right now. We don't need to worry about them. We need to worry about polygons, especially regular polygons. So a polygon is just a simple closed curve composed of at least 3 line segments called sides. That point at which 2 sides meet is called a vertex. So imagine a shape made of a bunch of angles, right? Now a regular polygon is a polygon with sides of equal length. So I had this chart made up for you, okay? And again, remember all this was discovered by the Greeks. Alright, so it's going to have a lot of Greek origin. And all these prefixes are going to be Greek. So a number of sides correlates with the name of the polygon. So let's say I have 3 sides of my polygon. I'm going to have a triangle. And I get all the way down to 10 sides. I'm going to have a decagon. Or 11 sides. I'm going to have an undecagon. Now think, tri means 3. Quad means 4. Penta means 5. Hexa means 6. Hepta means 7. Octa means 8. Nona means 9. Deca means 10. Now un means 1, if you ever think, I don't know, even Spanish, uno, right? So, deca, if deca is 10,